In this section, we will explain the principle of the working of the digital axle counter system with the help of a three-dimensional computer modeling and animation. This is the 3D model of the single-section digital axle counter system. In this animation film, the surface has been made transparent for educational purposes. We shall first introduce you to the parts of the SSDAC system. We will of course assume that all the parts are connected as prescribed. The system comprises of two pairs of web-mounted TX and RX axle detectors fitted at each end of the section. One pair of location box that houses one SSDAC electronic unit, one vital relay box consisting of two relays, and one pair of surge voltage protection device, a pair of suitable battery charger with battery, and a pair of reset box kept in the station master's room. Also, trolley suppression track circuit in case of amplitude modulation type only. The units are to be installed near the track side in the beginning and end of track section, that is outer limits of the section. The SSDAC unit of the digital axle counter system is manufactured in a 3U height and 42T width, that is top enclosed. The system comprises of 8 plug-in modules. All the cards are of extended single Euro size, that is 220 mm into 100 mm, that plugs into a motherboard. This diagram shows the front view of the system and position of the PCB, and this is the rear view of the system. The cards must be inserted from card 1 to card 8, starting from left. The main features of the signal conditioner card are carrier signal generation, demodulation, pulse shaper and pulse generation, phase reversal detection, that is for phase reversal type axle detector only, and supervisory signals generation and detection. These cards show the following LED indications. OSC OK. The green LED will glow in oscillator OK condition. LD OK. Green LED will glow in level detector OK condition. Pulse OK. The green LED will glow in pulse OK condition. TP CON. This LED will glow when the trolley suppression circuit is connected. The main features of the microcontroller logic block card are industry standard 8051 microcontroller based architecture, on-board RS-232C compatible serial port for modem connectivity, on-chip flash ROM for program storage, on-chip RAM, parallel ports for address or more input, pulse inputs and vital relay outputs and relay reback, 8 LED block for count progress or error display, and two independent LED indicators for section status. These cards show the following LED indications. 8 LED block. All the LEDs are red. These LEDs are off and glow whenever error occurs. Clear. This green LED will glow to show the clear condition of the section. Occupied. The red LED will glow to show the occupied condition of the section. The main features of the event logger card are: it has 2 MB flash memory, onboard real-time clock for date and time, 6 mAh battery on the card, data downloading rate up to 38.4 kbps, provision for data downloading or data analysis, and report generation using data analysis software. This card shows the following LED indications. Run. This LED blinks continuously, showing the normal working of the card. Log. This green LED will blink whenever the data is logged into the flash memory. It will start blinking approximately after 2 minutes. DNLD. This green LED will glow whenever the data is being downloaded from the flash memory of the card and will stop glowing when the download is complete. The main features of the modem card are: it has FSK full duplex modem chip, V.21 mode of operation using 2 wires, baud rate of 300 bps. It has originator, that is entry unit, and answerer, that is exit unit, for V21 selection. Automatic gain control, and it has SSDAC reset circuit with voltage and timing window function. This card shows the following LED indications. TX. The green LED will flash and indicate the signal transmission information from the local unit. RX. The green LED will flash and indicate the signal receiving information from the remote unit. Mode. The green LED is normally off. When the system is made off and on, the LED glows and again goes low when the system enters a self-test after a successful reset. CV. The green LED will glow when the carrier is detected. The main features of the relay driver or the card 7 are: it has dual clock checking circuits, opto isolator circuit, vital relay drive output, preparatory reset or the PR relay drive output. This card shows the following LED indications. MLB1 clear. This green LED will glow when the section is clear. MLB1 clock. Flashing of this green LED indicates the presence of clock to relay driver card. MLB2 clear. The green LED will glow when the section is clear. MLB2 clock. This green LED indicates the presence of clock from MLB2 card after counts are balanced in the section. Relay drive. This LED indicates the presence of relay drive output to the Q-type relay from the driver card. The main features of the DC-DC converter card are as follows. It has low ripple. It has a wide input line regulation. It has very good load regulation. It has input and output protected for short circuit. This card is immune to EMI or RFI interference. This card shows the following LED indications. Plus 5 volt LED. This LED indication suggests the presence of plus 5 volts in the DC-DC converter card. Plus 12 volt LED. This LED indication suggests the presence of plus 12 volt in the DC-DC converter card. Plus 24 volt LED. This indication suggests the presence of plus 24 volt in the DC-DC converter card. And plus 15 volt ISO LED. This indication suggests the presence of plus 15 volt in the DC-DC converter card. After having discussed the functions of the various cards, we will now talk about the working of the digital accel counter system. When the power is switched on, the power supply from the battery and the battery charger is supplied to the electronic counting board. The SSC1 card generates 21 kHz of 38 volts RMS AC voltage, which is fed into the transmitter coil TX1, and SSC2 card generates the 23 kHz of 38 volt RMS, which is fed into the transmitter coil TX2. The voltage in the receiver coil is produced due to the flux linkage between the transmitter and the receiver coil. In the amplitude modulation type accel detector, the strength of the signal receiving RF coil is approximately 750 to 1200 millivolts, which depends on the rail size. In phase reversal type accel detectors, the strength of the signal received in the RF coil is approximately 275 to 600 millivolt, which depends on the rail size. These signals are then fed back from RX1 and RX2 to card 1 and card 2 respectively. In the meanwhile, the system remains in the pre-post stage and the section is shown as occupied. To make the system ready, reset command is given to the system station master. When reset command is given to the system, the prep reset indication flashes and 48 volt is extended to the counting unit. Similarly, the remote system is also reset by far end station master and both the systems synchronized and the prep indication becomes steady. The reset counter is increment by 1. The accel counts of both the field units now become 0. System attains preparatory reset stage and the PR relay picks up. When a pilot train passes over the TX-RX coil at the entry end, the passing accels are counted and stored as in counts in the system. Similarly, When the train reaches the exit end of the system, the passing axles are counted and stored as out counts in the system. After passage of the pilot train in the section, balance of the in counts and the out counts is verified by the system. Minimum of 2 in counts and 2 out counts are to be recorded for clearing the preparatory reset stage. After this, the PR relay drops and the system enters the clear state, and VR relay picks up on both the sides. The section is now shown as clear in the system. The SM reset box also provides the status of the section, clear or occupied, to the station master. Thereafter, whenever a train enters the section, the system indicates occupied, and when the train completely leaves the section, the system shows clear. The axle counts are incremented or decremented according to the train direction. We will now explain the details of how the counting takes place. For education purposes, the axle detectors are designated as follows. At the first detection point, the transmitter coil of 21 kHz TX and the receiver coil of 21 kHz RX, TX1 and RX1 are designated as track device A. Transmitter coil of 23 kHz TX2 and receiver coil of 23 kHz RX2 are designated as track device B. Similarly, at the other end, transmitter and receiver coil of 21 kHz as D and transmitter and receiver coil of 23 kHz as C respectively. When there is no wheel on the track device, the flux on the TX and RX coils increase. The carrier signal in the form of uninterrupted sine waves is always present. The output of the SSC cards are as follows. When the wheel passes over the track device, the flux between the TX and the RX coil is interrupted as shown. And the carrier sine waves are interrupted as follows. Ensure that after modulation, the amplitude of the RX coil signal is equal to 10 to 15% of the normal amplitude of the RX signal in amplitude type modulation devices. Ensure that after modulation, the phase of the RX signal changes to 170 degrees to 180 degrees with reference to the reference signal in phase type modulation device. This modulated signal is then processed and extracted by card number 1 and card number 2 and is converted into 5-volt pulses, which are then fed into the MLB cards. When the wheel passes over the track device A, the following pulse is received at the MLB card. Similarly, when the wheel passes over the track device B, the following pulse is received at the card 4 and in count is registered now. Since the in count from modulation signal from track device A is received and processed before the modulation signal from track device B, the direction of the wheel movement is A to B, that is, in this direction. When the following sequence is complete, it is counted as 1 in count. Because of this, the section is shown as occupied at both the units and the station master reset box. Similarly, when the train passes from the second detection point at the other end, that is the track device D and track device C, the following pulses are generated in the evaluator. The out count is registered now. As the modulated signal from D is received by C, the direction of the movement of the wheel is registered from D to C, that is, in this direction. When the following sequence is complete, it is counted as one out count. When counts are balanced at the entry end and the exit end, the vital relay picks up at both the ends. Now, let us assume a trolley with 12 axles enters the section. At the entry end A and B, the in counts are registered 0 to 12. We have shown the in count increment in stages. The track section is now indicated as occupied. At the exit end, D and C, the out counts are registered 0 to 12. The track section is indicated as clear. In case of movement of wheel in reverse direction, the in count will be given by C and D and the out count will be given by B and A. Similarly, in case of motor trolley movement, when the motor trolley with 2 axles is moved into the section, the following signals are generated. At the entry end, the in counts are registered 0 to 2. The track section is occupied. At the exit end, the out counts are registered as 0 to 2. The track section is clear. When the push trolley passes over the track device, the push trolley does not get detected by the device. Therefore, following pulse is generated by the device. Cut.